Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem from today, for June 5th, 2018, and it used to be my exercise number 21 for Exam FM, Financial Mathematics. Brian sells a stock short for $800 and buys it back 1 year later at a price of $805. The required margin on the sale is 62.5%, and interest is credited on the margin deposit at an annual effective rate of I. Dividends of 15 are paid during the year. Brian's yield rate over a 1 year period is J. If the interest credited on the margin deposit had been 1.25 I, with everything else remaining the same, Brian's yield rate over the 1 year period would have been 1.5 J. Calculate I. So Brian's margin deposit is 62.5% of the amount of stock sold short, which was 800, so that's 500. He receives interest in the amount of 500I. His total net income is, well, he has a loss because he sold for 800 and bought for 805. Plus, on the trade itself, has interest in the amount of 500I, and he has to pay a dividend of 15. And if you add it all up, that ends up being 500I minus 20. And J, the return on his trade is, well, he gets 500I minus 20. His investment is 500, so this is I minus 0.04. So 500I minus 20 divided by 500, that's I minus 0.04. If the interest credited on the margin deposit had been 1.25, his total net income would have been -5 plus 500 times 1.25I minus 15, so 625I minus 20. His yield rate would have been 1.5J, that's what we are told in the problem, but it would have been 625I minus 20 over 500, so that's 1.25I minus 0.04. These are two equations with two unknowns, and by substituting J equal to I minus 0.04 into the second equation, so these two equations we got J equals I minus 0.04 and 1.5J equals 1.25I minus 0.04. So we substitute J equal to I minus 0.04 into the second one, and what we get is an equation in which I is the unknown, and the equation ends up being something that says 1.5I minus 1.25I, which is 0.25I equals 0.04 minus 0.06 minus 0.04, which is 0.02. So I is 0.02 over 0.25, which is 8%, and that's answer E. Please remember this is copyrighted material. The problem itself belongs to Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.